Hey guys, this is the last video in my sequel on emotion recognition tutorials. Let's have a quick review on the first two videos. In the first video, we trained Vgg16 on fall 2013 by Pytorch Lightning, and under our training regime, we were able to obtain the accuracy of 71.58% on the test set. In the second video, we deploy our model and do inference on image, video, and live webcam. In fact, I was little unhappy with the performance at 71.58%. If we look here, this is the benchmark for this dataset. We see that the state-of-the-art dataset is about 77% using an ensemble of 6 CNNs. I have tried a few tricks that I learned here and there, and I was able to improve the earlier number by almost 1%. So now the new accuracy is 72.5%. I will show you exactly what are the changes that I made in order to achieve this number. Well, let me bring it here. So for the data, everything is the same. The processing of the data is the same. For the model, so if you want a reproducible result which is similar to what I obtained, you should set the random seed at 1442. For the model, I made two changes. So the first change is I create an initialization for the weights. So here, whenever we have a module which is linear, then we will init the weight to be sampled from a standard, to be sampled from a normal distribution with mean 0.2 and standard deviation 0.02. And for bias, we initialize it to 0. Whenever we have an NN dot embedding, we initialize the way to have mean 0 and standard deviation 0.02. This is a trick that I have seen in many places, and it seems working. The second change that, after we define these init weights functions, we will apply it at the end of the init of the model here. So that the weights will be initialized based on this rule. And the second change that I apply here is on the learning rate scheduler. So in this learning rate scheduler, I use cooldown, two new parameters, cooldown and patience. Cooldown is basically the number of epochs that you would like to keep the learning rate the same before you reduce it. So here, every time we change the learning rate, we will keep the new learning rate the same for 5 epochs, and after 5 epochs, we will reduce it. Patient here means that for the first 10 epochs, we will not change the learning rate. So the learning rate is only changed from the 11 epoch onwards. And here I also set the minimum learning rate equal to 1e minus 6. Using these two changes, I was able to train the model for, I trained it for about 150 epochs, and I was able to obtain the accuracy of about 72.5% on the test set. I will illustrate this accuracy when we go through the code later. If you are able to do better than 72.5%, please let me know. In the video today, we will apply object checking on top of emotion recognition. The checker that we are going to use is SORT. First, let's discuss what object checking is and what it is used for. So here I would like to go to Google, search for object checking SORT. Object checking is basically a task which involve locating and following the movement of objects in a video or in a sequence of images. For object checking to work, there are two parts in it. First, we have to detect and localize object in a frame. This is often achieved using detectors like YOLO or RCNN. After detecting the current position of the object, an object checker will predict the future motion of the object using various estimation techniques. Well, the algorithm that we are using for this video is called SORT. So this is a real-time effective checking algorithm. As before, there are two phases in doing object checking. The first phase is detection, where we use model like YOLO or RCNN to identify objects in a frame, in the frames of videos or live webcam. The object checker came into action in the second phase, that is the estimation of the positions of the objects. So detection from current frames will be propagated to the next frame by estimating the position of the objects. Well, if we compare between using checker and not using checker, the results of using checker is usually visually smoother, as it constantly checks the movement of an object. Now let's go to the code. First, we will need to install SORT. So here we go to the repo of SORT. Well, I actually have tried to install it using the instruction here, that is to install requirement and then run it. However, I think there is some problem with installing the requirement on my device, so I was unable to install it using this instruction. What I am going to do is I'm going to clone this repo into my computer and then just run on it. So here I will go to VS Code. Well, I should have copied the directory to the repo. I will go to the VS Code, clone repo, and hit clone. I will save this repo on my desktop. Alright, so this is a repo in GitHub, and it also appear in my desktop here. Now I am going to create a Jupyter notebook, which I will put in this repo. So let's create a new notebook here, which we call motion recognition check, and we will work on this notebook. Well, first let's load the model with the pre-trained weight. One pre-trained model. So here's a model that we go through in the first video. However, note that there are two changes that I made here. One is in the initialization of the weights, and the other is in the learning rate scheduler. Now we will load the model from the checkpoint path. So here is a checkpoint that I downloaded to my laptop, and we will initialize the model with parameter from this checkpoint, Vgg16 from checkpoint path. So load from checkpoint path. Maybe we also want to print the number of parameters of this model, so we use p sum of p dot numl for p in model dot parameters. Here I will print in million. Okay, so we have loaded the model and the number of parameters is 14.7 millions. Now we want to test the model accuracy on that set. For this, we will first set up a trainer, which is a Pytorch Lightning trainer, and we'll do a trainer.test on the model and the test loader. So here I have not created the test loader. In fact, one thing you can do is certainly to copy and paste the data module that we discussed last time. But here, to avoid this, for this notebook to be too long, I will just import it from a file that I already write from data import. So I just need the test loader. Well, here I already write a data file, which is exactly the file which I write before, and on this file I already get the chain loader, validation loader, and test loader. However, I only need to choose a test loader. Now let's run inference on the test set. So here we simply use trainer.test in order to run the inference. It will take some time for this to load and run. So here in the meanwhile, let me write out what we are going to do for the later sessions. So later in the next sessions, we will do inference on video. We will apply the model and we will use SORT as the checker in order to check the movement of objects in the video. So basically, in our case, we will check the facial regions that is detected by face recognition in our video. So here the validation is done, and we can see that the accuracy on the test set that we obtained is 72.499, that is about 72.5%. For inference on the video, first I will copy again the transform test, which is used for running inference, and again this is the list of emotion. To run video inference, I will write two functions. I guess here I haven't imported the necessary module. So I need to import cp2 face recognition. Let's just use time. So now we will import the SORT checker from SORT in order to print out some progress for the running. I will import the QDM, and here the first function that I want to use to make video inference is to draw boxes and put text. So this function will take in a frame, a video frame as the input. It will take in the bounding box. These are the coordinates of the facial regions in the frame, and it takes in predictions for these facial regions. So here bounding box is list of facial regions which come in the form top left and bottom right. Predictions is a list of predicted emotion for the facial regions. Now we are going to look through all the bounding box and the prediction, and then draw rectangle with the predicted emotion on the facial regions. So draw for bounding box prediction in zip bounding box predictions. We will extract the coordinates of the top left and the bottom right. These coordinates might not necessarily be integers, so here I will convert them to integers. And now first we will draw rectangle with these coordinates. Here the lines for this rectangle is the light color is number 1. Thickness, let's put 2. We also draw another rectangle which is mainly used to create region to write the emotion. So here colors is the same. And we want to have a few of colors here, so we put -1. Lastly, we will put text, which is the emotion. Alright, so after drawing, we will return the frame. From sort, import, sort. No, from. Well, one thing that I notice is when I use Jupyter Notebook with this sort, I always get this error, but it doesn't seem to affect anything, so let's skip about it. Now we will do video inference. First, we would like to capture the video using the video path. We want to extract the width and the height. Cap.get3 and cap.get4. We also want to extract the FPS. Let's a number of frames. Let's put them in this way. Frames count. Well, maybe let's print out how many frames that we have for our video. And also print out the FPS. Here I will also create a codec to write into a new video. So after we process the frames, we get a new frame, and we would like to write a new frame into a new video. So for this, we will put pass up to the last 4 characters, because the last 4 characters in my case is .mp4. So we will give out .mp4 to distinguish with the original video. We would use the mp4 format for the output video as well. And here we want the output video to have the same FPS, same width and height. Alright. Next we will initiate a sort checker. So let me explain the parameter here in a moment. Well, so in this sort checker, we have 3 parameters: max age, min hits, and IOU threshold. For max age here, I set to 30, maybe this is a little high, 10. So this is the number of frames in which if we lose checker, if we lose the object in 30 frames, we will discard the checker. We will no longer put a checker on that object. So the tolerance level is 10 frames. Min hits here means we only start a checker if the object has appeared in 3 consecutive frames. And IOU threshold here, IOU stands for intersection over union. So we set the intersection over union to be 0.3. Well, here before running the checker, I will set a progress bar just to indicate how our progress is so far. TQDM, the length of the bar should be total number of frames, and we start from 0 frame. Next we are going to read frames, make inference and draw it in a new video. While true, first we will update the progress bar. So now we will read the frame. If let's say at some point some frame is not successfully read, we will break out. So now assume we have a frame that was successfully read. We will get prediction for the facial regions of that frames. We will initialize detection as an empty list. So here detection is a list of bounding box coordinates which has 4 coordinates: left, top, right, bottom, and score. So this is the score for the prediction. Let's say our model predict the emotion happy with confidence score of 70%. So this score is 0.7. And we also want to have another list. of prediction for facial regions in the frame. We will first extract the location of the facial region. So we use face recognition dot face location on the frame, and now we are going to get predictions for all the faces with touch dot no grad. So here we are going to choose the model. We don't want to waste memory on checking the gradient. So here we will look through the face coordinates, which come in the form top, right, bottom, left. So this is the format of location for face coordinate that was produced by face recognition. So we extract the facial regions. Since our model only accepts grayscale image, we will need to convert this facial region to grayscale. So face gray equal to CV2 convert to color face CV2 BGR to gray. Not only that, we also convert this, we also resize this to size 48 by 48, which is the size of our data set. And here let's have data type as UINT8, and in order to make evaluations, we need to use transform test on these facial regions. So transform test only apply on image, so we will convert this array to image first before we apply transform test. Right, so here regarding the size of the thing that we are doing, in the last step we have a collection of 10 sub-image. Each of them have one channel because it is a grayscale image, and each of them has shape 44 by 44. Our image, the one that come before, has shape 48 by 48, and remember that our transform test randomly crop 48 by 48 image into 10 sub-image of size 44 by 44. The prediction will be the average prediction on these 10 sub-image. Model.eval. So when we run the model here, the output will be 10 times 7. We get 7 logits for the 7 emotion, and we need to take the average. So after taking the average along the first dimension, we will get 7 logits. So here we want to compute the scores of these 7 logits. So we will use softmax touch.nn. I think I already imported this as f. So I simply choose f.softmax. Well, now our prediction will be argmax of this score, and the score for the prediction will be scores at the max position. Okay, so now we are going to append the result to detections. Detection, append. Our detection need to come in the form of tuple of 5, in which 4 of them is a coordinate for the bounding box, and the last one is the score. So here the first 4 will be in the format of top. Sorry, we start with left, top, right, bottom, and the last one is score. For prediction, we simply append prediction, append pred. Alright, and finally we will convert all these to NumPy array, because that is the format which will be fed to the sort checker later. Detection and also prediction. Now we will do the checking. Note that in the sort checking, we also need to handle the case where there might be no detection in a frame. So in that case, basically this is an empty array, and we need to handle this case. So if length of detection is equal to 0, we will initiate detection to an empty array of size 0.5. On the other hand, now we can run the sort checker, which we initiate, should be up here. We can run sort here, sort dot update on the detections. So basically what this gives is new bounding box and score. Based on the current positions, based on the current bounding box and score. Here we are not going to use the score in our sketching, in our drawing on the facial regions. We will only use the bounding box. So we will extract out everything except for the last column. The last column is for the score. And now we will draw bounding box and text using the draw function that we already write. So p frame is draw boxes on frame with the list of bounding box and predictions. And we will write p frame into a new video. Well, that is all we need. And after we finish, we will release all the video and destroy all windows. Now we are going to make inference on a sample video. The sample video we are going to use is the same as the one last time. It is a discussion between Elon Musk and Jack Ma. So here the path to the video in my local computer. We also want to time the inference. So here I want to print out in minutes. Yep. Module object is not callable. Time, it should be from time import time. CV2 dot color. This was not updated yet. Right. S type np.uint. Module number have no uint, not ut. So this should be uint8. Well, I'm not sure why when I run this sort checker, it make my Jupyter notebook quite unstable. I'm not sure because of the error in the Jupyter notebook or because of something in the checker. Alright, so now we can see that it's running. It could take a few minutes to run this, and we will see the result. While it is running, I also want to bring back the function that combine video and audio that I wrote last time. What we get as the output of this process is just a video which is a sequence of frame, so there is no audio in that video. Here is a function that I write last time to combine the output video with the audio of the original clip. Well, we'll wait a few minutes for this to finish. In the meantime, let's do some coding for live webcam. Well, for live webcam, again, our goal is to integrate the sort checker into our facial detection algorithm, so that when it is shown live, the visual will be smoother. Well, so here for this, I am going to write a class and then initiate the class emotion detection. The attribute here, capture index, is the camera index. Self.model is the model. We also want to have emotion as an attribute. Right, so in this class, I'm going to write a few functions. The first function is called predict on the frame. So what this function does is return a list of bounding box and prediction on facial regions of the frame. It is pretty much identical to what we did for video, but here maybe to make things look neat, I will wrap everything inside a class. And inside this class, we also want to draw the bounding box. So So again, this is exactly the function that we see before. And then for this class to run, I will try a call a method. So basically in this call method, we will open the camera, loop through the frame and run it. Well, let's see whether we are finished here. We are still at 70%. So let's implement some of these functions. We will start with the longest one, which is prediction. So here, because everything is just very similar as before, I'm not going to code this, but I will copy what I already did, and we'll discuss about it. So I think I over. Well, so we initiate the list of predictions and detections as empty array, put the model to evaluation mode. Well, it's probably good to have a touch.nograd when we call this function. This is like a context manager. So whenever we call this function, gradient is not checked. Here we also loop through all the facial regions to give predictions. We convert them to grayscale image, resize to size 48 by 48, randomly crop the face image into 10 sub-image, make prediction based on these 10 sub-image. It is exactly the same as before. And here we will return prediction and predictions. The function drawbox is in fact also identical. So I will just copy what we did before. The difference now is in the call method, because unlike video, we need to fit in the frame live. So first we will capture. We will open the camera. Well, maybe let's go back to the thing here, and we are finished in 5 minutes 59 in 5.6 minutes, and let's run this to convert the video without audio to a video with audio. Now let's look at the result. Hopefully we see some tracking effect in the new video.
Don't worry about machines. For sure, we should understand one thing, that man can never make another man. Computer is a computer. Computer is just a toy. Man cannot even make a mosquito. So we should have confidence. Computer only have chips. Man have the heart. It's the heart where the wisdom comes from.
Well, so here, if you observe closely, you can see that there is some zoom in, zoom out effect, which means the checker did it work. Right? It's zoom in, zoom out effect is due to the checker, so it basically makes the rectangle smoother. Now let's get back to our implementation on live webcam. So we have implemented the predict function, in which we return two NumPy arrays. One is for the detections of the bounding box, and one is for the predictions. And we also implemented draw boxes. That is to draw bounding box and label the emotion on a single frame given the bounding box coordinates and the prediction. The only thing that we haven't done is the core method for this class. So we will first have a video capture and put in capture index. Now assert that cap is open. Now we will initiate a sort checker. So sort here take in 3 parameters. Max age equal to 30 means that if we lose an object for 30 frames, we will discard the checker for that object. Min hits will be initiated at 5. That means we will initiate a checker if an object has appeared in 5 frames. IOU threshold is set to 0.3. The intersection of a union is set to 0.3. Well, let me put an explanation here. Max age is the maximum number of frames that are allowed to lose checks, lose the object. Mean hits is mean number of frame. Mean number of frames that are required to initiate a checker. Well, so now we will load the frame while true. Success frame. We will assert that we only process if we have a success. One trick, and we also use this trick in the last video in order to have faster speed in the facial recognition module, is to resize frame by factor 1/4. So instead of using the face recognition on the original frame, we would use it on a resized frame. And now we will give predictions. We will get the detection and predictions on this resized frame through the function predict. Now note that the predict function gives us a list of detections for the bounding box of the face, and also prediction for the emotion of the facial regions. Because we resize the frame by 4, we also need to times 4 to get back original positions in detections. So note that detections is a list of top, left, bottom, right, and score. Right. So here we want to rescale the first 4 coordinates. Why we need this format? This format will be the input for the sort checker that we are using here. Here I'm not sure whether there is a quick way to modify an array, but here I just use a very inefficient way, that is to run over all the detections and then resize all the rows, and then resize the first 4 coordinates of row by a factor 4. So now we get back the real bounding box of the original frames by doing this rescale by 4. We will do sort checking on the real coordinates of the bounding box. So here when we do the sort checking, we also need to handle the case where no detection is obtained, which means there is no bounding box in the frame. So if length detection equal to 0, we simply define it to be an empty array. Otherwise, results will be sort.update detections. This result is new positions for the bounding box. Well, which come in the form, I should say, new position and score of bounding box new and score new. However, in this case, we only need to use the bounding box for drawing purpose. So we will extract the bounding box. The score here is the last coordinate in the last column of results. So bounding box, we take all the previous columns except the last one. Now the frame will be replaced by draw box, self frame, bounding box, and predictions. That's it. All that are left is to show this frame, say emotion detection, check on frame, and set up an escape key. So whenever we hit an escape key, we will break out of the video stream and we'll do a cap release and destroy all windows. Alright. Only need one. Now let's rerun this block of code. Well, it looks fine. However, be warned that there might be a problem when I call an instance of the class now. I have noticed that whenever I try to open the webcam in Jupyter Notebook, my Jupyter Notebook often crash most of the times. So before I made this video recording, I already tried multiple times, and a few times it do not crash, but most of the times it crash. Let me show you exactly what is going to happen. Okay, so here it just say Python quit unexpectedly. Honestly, I have no idea how to fix this on Jupyter Notebook. However, I also know that I can do this on Visual Studio Code. If you know the solution to this problem, please let me know. For now, I will open my Visual Studio Code and run on Visual Studio Code. In this VS Code file, we simply combine everything that we did in our Jupyter Notebook. So here we have import of all the package. We first create the model, and then we load the model from the checkpoint path, in which we train and get the accuracy 72.5%. We also print out the number of parameters for the model. And here, transform test is used for inference. And here is the list of emotion. Next is a class emotion detector that we have implemented. So in this class, we define the predict function that gives us a list of predictions and detections. So predictions mean the emotion for the facial regions that appear in the frame. There can be multiples of them. And detection means the list of bounding box and score. Right? So here score is like the confidence score for the detection. We also have draw box to draw bounding boxes around the facial regions and also mark the emotion on the bounding box. We have the core method in which we capture the video, the webcam. We initiate a sort checker. So in this case, I set max age to 30. So that means the maximum number of frames that are allowed to lose the object is 30. So if we lose the object in more than 30 consecutive frames, the checker will be discarded. Min hits here is the minimum number of frames that are required to initiate a checker. So if we detect an object in at least 5 consecutive frames, a checker will be initiated to check the object. IOU threshold is the intersection over union, and it is set to 0.3. We basically read the frame one by one and then process them one by one. The part that we use the checker is here, where we use it to update the positions that are given by face recognition. So these new positions come from the checker, and when we apply the new bounding box using these positions, it gives us a smoothing effect on the facial regions, and I hope that will be seen when I run this file later. And the rest is just to show it. And here we initiate an instance of the class and then call it. Now let's run this file. Well, you can see that when I make the movement, there is some zoom in, zoom out effect on the rectangular boxes. So certainly the checker is doing its job. However, I notice the classification result here seems a bit off, because when I run this before, usually my emotion is neutral. However, maybe now it's at night, the lighting condition is not good, so my emotion here seems to switch back and forth between neutral and fear, and in fact most of the time it's fear. Alright, so that's it for this video. If you like it, please give me a like, and see you next time.